Hi everybody, this is the first short video for the subject Advanced in Organic Chemistry 2, which deals with organometallic compounds. In Unit 1, we are addressing some fundamental concepts, and in particular, in this video, we will highlight the milestones in organometallic chemistry. The cradle of organometallic chemistry is a Paris military pharmacy. It is there that Cadet works on invisible inks based on cobalt salt solutions. For their preparation, he uses cobalt minerals that contain arsenic. Cadet's fuming liquid was a red-brown oily liquid prepared by the reaction of potassium acetate with arsenic trioxide. It consisted mostly of tetramethyl diarsine known as cacodyl or dicacodyl, and also cacodyl oxide. These were the first organometallic substances prepared. The so-called size salt, potassium trichloroethylene platinate 2, isolated in 1827, received a great deal of attention during the second half of the 19th century because chemists could not explain its molecular structure. This question remained unanswered until the determination of its X-ray crystal structure in the 20th century. It is not only the first olefin complex, pi-bonded organometallic, but also the first transition metal organometallic compound. We will study the bonding in this family of compounds in Unit 9. In 1849, Franklin prepared the first main group organometallic compounds. He was carrying out experiments aimed at the isolation of the ethyl radical by the action of a zinc on ethyl iodide. Thus, ethyl zinc iodide and diethyl zinc were the first alkyl zinc compounds and hence the first main group organometallic compounds. Despite its highly pyrophoric nature, the ethyl zinc is an important chemical reagent with plenty of different uses. In organic synthesis as a source of the ethyl carbanion, in material science chemistry as a zinc source in the synthesis of nanoparticles. Also, it is important in polymer chemistry. In this case, it can be used as part of the catalyst in leaving polymerization, and many others. Franklin synthesized other several air-sensitive metal alkyl complexes of zinc, mercury, tin, boron, etc. The mercury and zinc complexes being immediately used to synthesize many other main group organometallic complexes. Franklin also introduced the concept of valency, combining power, and the term organometallic. In 1863, Friedel and Crafts were the first to use organometallic compounds, alkyl zinc, to synthesize silicon monomers. We will study these compounds also in Unit 3. In 1890, Ludwig Mond obtained the first binary metal carbonyl by serendipity. By the time of the discovery, he was investigating the rapid corrosion of nickel valves used in apparatus for the Solvay process. Remember that that is the process used to make sodium carbonate, also known as soda ash. Indeed, it was because of problems with corrosion of nickel parts in the Solvay reactors, he traced the presence of carbon monoxide in the carbon dioxide used to flush ammonia from the reaction vessel, and thus Mond and his co-workers first started to investigate the reactivity of nickel and carbon monoxide. Unit 7 will deal with transition metal carbonyls. 1839, Barbier replaces zinc by magnesium in reactions with alkyl iodides. But this reaction is explored in more detail by Barbier's student, Victor Grignard, who was awarded with the Nobel Prize in 1912, sharing it with Sabatier. Grignard's name is forever engraved in the history of chemistry for the reaction of magnesium with organic halides, leading by oxidative addition to Grignard reagent magnesium alkyl halides. The first half of the 20th century was especially noteworthy for the emergence of catalysis, and also many seminal discoveries were made in Germany. You have heard of, or surely you will this year, about the Fischer-Tropsch process, Rellens-Oxo process, Reppes tetramerization to cyclooctatetraene, etc. Curiously, there were only a few advances in the discovery of new complexes during this period. Iodidotrimethylplatinum, synthesized by Pope at the beginning of the 20th century, constituted the first sigma organotransition metal compound. Also, in 1909, Ehrlich, who the year before had been awarded the Nobel Prize in Medicine for his developments in chemotherapy, introduces an organoarsenic compound, salvarsan, for the treatment of syphilis, thus becoming the first modern chemotherapeutic agent. Going back to Grignard's discovery, we have to say it had an enormous impact not only on organic chemistry, but also proved to be of considerable importance in transition metal organometallic chemistry. For instance, in 1919, Hein synthesized what he believed to be a polyphenyl chromium derivative. However, some 36 years later, it was revealed that the compound possesses a pi sandwich type structure. In 1931, Hieber prepares the first transition metal hydride complex. It is in the 50s that inorganic and organometallic chemistry boomed. In England, too, several chemists had noted at the beginning of the 50s this very stable orange powder that formed when cyclopentadiene is passed through iron tubings. Kelly, Pawson, and Miller first published the compound in 1951, and Pawson reported the structure in the journal Nature. The structure that is written there, that is, with iron sigma bonded to a carbon atom. In doing so, he made the same mistake as Hein 32 years earlier. In the meantime, however, Sidgwick had published the 18-electron rule for transition metal complexes. You will learn a lot about this rule in Unit 4. And Pawson's proposed sigma structure for bis-cyclopentadienyl iron only had 10 valence electrons. Meanwhile, at Harvard University, Wilkinson and Woodward, recognizing Sidgwick's rule, immediately understood that Pawson's formulation was incorrect. A few months later, they published the first sandwich structure, just before Fischer. That was bis-cyclopentadienyl iron, ferrocene, and an 18-electron complex, in which the two rings are perfectly parallel, pi-bound to the iron atom and having aromatic properties. Thus, in 1973, Otto Fischer and Geoffrey Wilkinson received the Nobel Prize for their pioneering work on the chemistry of the sandwich compounds. If you do like to know more about the backroom story on this subject, it is really curious, Just look for it in Astruc's book, Organometallic Chemistry and Catalysis. Another very important discovery in 1955 was that of olefin polymerization catalyzed by soluble titanium and aluminum compounds by Ziegler and Natta. These authors were awarded the Nobel Prize for Chemistry in 1963. It was also during this period that George Wittig found the reaction that now bears his name, and that Herbert Brown discovered the hydroboration of olefins in 1956. They were jointly awarded the Nobel Prize in 1979. Finally, I have included the installation of the field of the pi-allyl transition metal complexes by Schmidt and Hafner in 1959. I have done so because we will work a lot with this kind of complexes during this course. Structural bioorganometallic chemistry has its origin with the English chemist Dorothy Crowfoot Hodgkin, who established the X-ray crystal structure of vitamin B12 coenzyme between 1953 and 1961 using a primitive computer and resulting in her awarding the Nobel Prize in 1964. Organometallic chemistry has really been around for millions of years. In 1962, Vaska published the famous 16-electron complex that bears his name. It is well known for the reversible addition of dioxygen, among others. In 1964, the first metal-carbene complex was published by Otto Fischer. In 1965, Wilkinson and Coffey independently discovered the first homogeneous olefin hydrogenation catalyst, known as Wilkinson catalyst. In 1968, Streitweiser prepared uranosine, and in 1973, Fischer obtained the first carbene complex. Let's finish with Nobel Prizes awarded in organometallic chemistry. Hoffman and Fukui for the isolovable analogy that we'll study in Unit 4. They were awarded in 1981. The Nobel Prize in Organometallic Chemistry in 2021 was for Sharpless, Knowles, and Nojori for their works on enantioselective catalysis. The Nobel Prize of 25 was for Chauvin, Schrock, and Gratz for the mechanistic and applications-oriented study on catalysts active in olefin metathesis. And finally, the Nobel Prize in 2010 was for Heck, Negishi, and Suzuki for palladium-catalyzed cross-couplings in organic synthesis.